The Tumaker Pellet extruder 3D printer just arrived. Dimensions are here, 24 by 28 by 26 inches. This whole thing, the crate with the printer, weighs about 100 pounds. It's time to open this up. Alright, the lid is off. Came off with 4 screws, and now we have this cardboard box. I'm going to tilt this and pull the cardboard box out. The cardboard box is out. Let's open it up. Here's the first layer with some tools and power cord. Here's my initial reaction to the machine. I haven't even taken it out of the box, and it's a beautiful looking machine. Aluminum frame. I tested it with a magnet. It's all held together here by screws or bolts. You can see the y-axis is driven by a single stepper motor with dual shafts going to either side with belts. And there's these nice round rails here. And then here's a rail for the x-axis. And it looks like they put in a heat break for the Tumaker extruder. Glass build plate. Yeah, look, even an LED strip, light strip. Alright, time to take it out of the box. Thank you for trusting in our products. Consult Simplify 3D and manual, you can go here. Okay. Very nice looking printer. Alright, let's open up this front door. Oh, that felt good. I like how it has the magnets built in here. It's a beautiful looking machine. Time to peel off the plastic. That's always a satisfying feeling. This box was under the build plate here. Contains a hopper which will connect right here. I like these little door magnets. They have like little stickers. I'm not sure if this comes as an assembly, like the magnet with the sticker, or if they just like put the magnet here and then stuck it here with this little clear sticker, but this is neat. I really like this feel here. Just for fun, I removed this back panel with this 3mm hex wrench, and this uses a Duet 2 main board. And you can see here the Espressif Wi-Fi module, SD card, input voltage, the steppers are wired in here, and there's labels for XYZ, extruder 0, so on and so forth. I decided to flip the machine onto its back, and wow, this is really neat. The power supply is here, and it's like sticking out and built in. It's really neat. I've never seen a machine quite like this before. And then you can see the SSR, probably for bed heat here, and then the Z stepper motor is sticking out too. The power supply outputs 24 volts at 6.5 amps. I noticed these belt clips here to prevent the y-axis from moving during shipping. Pretty clever. I'm going to remove them though, because I don't want to turn these motors with the belt clips here. It's plugged in. Let's power it up for the first time. Cool. Custom start screen. The lights turn on. To go from uncrating to the first power on, it should take about half an hour. It looks cool with the lights off in the room, but the machine on. The first real difficulty I'm seeing here is in the manual. It doesn't come with a hard manual. It says to go to this website here, so I did. Then I go here and then click NX Pro Pellet. It downloads a zip folder. In the zip folder are these two files. So I guess I have to open up Simplify, and this on the left is a .fff file, and to upload that to as a printer setting. Well, this is really neat, the console screen here. This is saying, well, this is really neat, the console tab here with this console screen. And it's saying the maximum predicted heat, 321C, Wi-Fi module started. And then, so this is the wireless network that it creates, and the IP address. Here's how it shows up in the Wi-Fi settings on my computer. I found a better link for the manual here. I'll put this in the description. It says the Wi-Fi network and password. My computer is now connected, and I'm going to try a couple things. And we can do this either from remotely, from my computer. I'm going to home X. Here we go. Alright, the first movement. Sweet. We could also do this from here, control. Let's do a home Y. Alright. Looks like that's the Z home switch right there. Let's do a Z home. Oh, cool. It even has like it decelerates as it approaches the home switch. That's a nice feature. Let's see if we can heat up the nozzle. We'll just try that. Set. We'll see what it does. It's already starting to go up. Neat. While that heats up, here's a quick overview of the machine dimensions. So this was the crate dimension and weight here. And then we have the actual machine outer dimensions, about 22 by 20 by 20 inches. Machine weighs around 65 pounds. And then there's the build volume. So we get about 11.5 inches of travel in X, 7.25 inches of travel in Y, and then 7.75 inches in Z. And we're over halfway there. Alright, we're at 220C for the extruder. If I try to extrude, I get this warning message. Here's the Duet web control panel here. And I always like this graph, how there's a graph showing the temperature versus time. And this input here is only at 120, so I wonder if this is why we're getting the error. There's a little bit of material coming out of the nozzle, and I took a peek inside of here, and there were a couple little pellets, so it looks like it was tested ahead of time. I just set the left basic to 220 as well, and you can see this is going up rapidly now. I'll try extrusion again once we hit it 220. There we go. There we go, it's working now. I press this and the screw spins. And it spins in the right direction too. The screw is going to force the pellets out. spinning like that. I've loaded some LX 175 PLA pellets into here for testing purposes. Let's see if we can extrude them. The nozzle diameter is unmarked. It's a custom nozzle. I measured it with my caliper, and it's about 0.8 millimeter diameter. What's neat is this comes with these two tools here for removing the nozzle. They have the head heated up, and this makes nozzle removal really nice. Here's the nozzle. I just removed it, and I think it's a M8 by 1 thread. Here's the typical nozzle for most 3D printers. It's an M6 by 1, and here is an M8 by 1.25 thread, and it's about the right diameter, but this thread is much more coarse than this. You can see they don't line up. And then here, this is an M7 by 1 thread, and they actually do line up pretty much exactly, but this is too small of a diameter. So I'm pretty sure that this is an M8 by 1 threaded nozzle. Let's try extruding here. We set this to 100, speed to 50. Alright, there it goes, there it goes. Took like 3 extrudes to get it to really go. Cool. Hey, there's a little bit of residue left from when they tested it at the factory. I just attached this hopper. I really like this hopper, actually. I was on the fence about it at first, but there's actually brass bushings at the end of the hopper here that they pressed or melted in, and it makes connecting this really easy and solid. The hopper holds about half a pound or 8 ounces of material of this LX 175 material, which I filled to the top here. To get this working in Simplify 3D, go to File, Import FFF Profile, and then you select the file that was in the zip folder earlier, the .fff file. That brings in the profile for the printer. And then what you can do, I have a STL file of a chess pawn here. Then what you can do is you go to Edit Process Settings, and then you can pick out your printer profile here from the drop-down list. And I have a couple other ones. I'm just going to say no, no, here. And then it's going to show you your nozzle diameter and all your printer settings. And here are the default printer settings. We have our retraction parameters, nozzle diameter, layer height 0.2 millimeters, and let's see here, skirt and brim, infill, 30% infill, supports, temperatures, cooling, max travel in each dimension, speeds, there you go. So here's what it looks like. I'm going to go to prepare to print, and 52 minutes is the estimate, 0.02 pounds, so we have more than enough material in the hopper by far. And then sometimes I like taking this slider here and moving it around and kind of watch how it's going to print. I move the x-axis just to make sure that we're not going to have a collision and everything looks good. So let's print now. There should be a couple different ways to print. I'm going to print from the Duet Web Control by clicking the upload up here and choosing the file. Here's our file. I like to put in the nozzle diameter and the temperature just to know what I'm picking. And I'm going to select it. Alright, it's uploading. The other way to run a program, I believe, is through inserting an SD card into the slot here. And we're off to the races. Here we go. I made a couple adjustments, specifically the layer height. I adjusted to 0.4 millimeters because it seemed like it was just too shallow of a layer height before. It wasn't really, it was kind of interfering. The nozzle was kind of interfering with the print. We're at about the halfway point of the chest pond print. 220C for the nozzle, 45 for the build plate. It's challenging to get things to stick to this mirrored finish build plate. The mirror itself doesn't really work in regard to sticking, so to get the chest pond to stick, I use this hairspray, and this has been working pretty well. If needs be, if I need to clean off the build plate, I'll use some isopropyl alcohol. But it's coming along here. It seems I'm having an extruder flow issue, and that could be for several reasons. The pond is almost complete, but the flow hasn't been consistent out of the nozzle. My guess is that it's too hot up top, and the material is kind of like pre-fusing together before it enters the main extruder zone. That's my first guess. I decided to take the extruder apart a little bit to understand how it works a bit better. At first I thought it was a straight up Tumaker pellet extruder, but now I realized it's a little bit different. So we have two heaters. We have the main heater block here down below. Then we have a preheater, the left preheater up here. And so two different temperature zones. As I suspected, we have a bit of a clog here. It was too hot up top, and some of the pellets pre-melted before they got to the screw. So if I tried to extrude here, we get this, but the pellets have clogged it. So I have to lower the temperature of that left side, the left side heater. I'm going to lower that, and I'm going to lower the main heat as well. So I'm going to try 160 up top, on the top left, and then 205 below. I'm also going to work this a bit, get these free, and extrude them out before loading pellets back in. Alright, all the material's been purged. We are about halfway through, and the machine is just printing beautifully right now. We have 220C at the lower heater, 160 at the upper left, bed is at 45C, and the machine, we're looking great here. We're looking great. I took off the hopper right now just to make sure there's no clogs in here, and everything's looking good. And there we have it. Took 31 minutes to print. It's on there pretty solid. There it is. I'm often asked how much can the pellet extruder extrude, and so I made this macro here. This corresponds to amount, and this is speed. And this is really the max speed I can get without hearing the stepper torque out and go And now let's run the macro. and we're going to see how much material this can extrude. Well, this sample weighs just over a gram, took 49 seconds, so about 89 grams per hour. This print is about 3.5 inches long, and it takes the printer about 1.5 seconds to traverse the length, and this turns into about 1,000 millimeters per minute, which is a lot lower than what the slicer says, but hey, that's the actual value. The slicer XY value has 9,000 millimeters per minute. Well, that about wraps it up for this video. Thank you for watching, and this is quite a neat printer, and take care.